I'm Chad Risco. I'm an assistant professor in the Department of Chemistry in the College of Arts and Sciences, and I'm also an affiliated researcher with the Center for Applied Energy Research. I grew up in a small town in Kansas, and math and science were always things that I was kind of good at. But honestly, I couldn't have told you that there was a career to be had in doing research. I went to undergraduate, had a really fantastic undergraduate research advisor who pushed me towards chemistry. And from there, when I went to graduate school, the research bug really took hold. It was being in the lab, working with people, trying to understand ways of solving problems, and that really motivated me to pursue a career in research. I think when people think of chemists, they think of the person standing at the bench in the white lab coat, wearing the safety glasses and, mixing things in different beakers. And that's not what we do. Our research is focused on computational and theoretical materials chemistry. And so I do my chemistry on a computer. We try to take knowledge from quantum mechanics, from classical mechanics, from chemistry, from material science and engineering, and bring it all together to provide a really fundamental understanding of new synthetic materials. So we start at the atomic level and go up. Our goal in the end is to really help our colleagues design new materials. We would like to be able to come up with some new concept, know how we want to describe it, let the computer run through all the different possibilities, and then come out with sort of the best answer. And then we can take that answer to our colleagues that actually make new materials and say, try this because we think that this is going to have some particular characteristics that are going to be of interest. We have a lot of work in batteries on campus, starting fairly small with lithium-ion batteries to large grid-scale storage. We're working with groups to understand those materials. And you think of a battery as a device, but it's really chemistry that takes place inside of it, and it's chemistry that runs away in those devices that sometimes lead to the explosions. And so how do you control that is a really critical question. And this is where I think the playground of the chemists comes in. I've been at the University of Kentucky for 3+ years now. And for me, in terms of the inspiration that UK provides, it's the people. I think it starts with the students, both the undergraduate and the graduate students, because, they're what makes a university, right? They're what brings a university alive. Seeing them progress as scientists, watching them learn to be better thinkers and gain new knowledge as they move forward. For me, I think that's probably one of the biggest things that I really appreciate about being a researcher. But at the same time, it's my colleagues. We have really fantastic collaborations with people not only in the department out here at the center, but also across campus. There's some really fantastic research that's going on here. For someone who's going to be coming to UK to do research, I would tell them to be open. Be open to collaborations. Be open to people knocking on your door, asking questions. It happens a lot. I can say that it's taken my research in directions that I would have really never imagined.